Ladies and gentlemen, welcome to GGKP's webinar titled Introduction to SCCP, MCCP and PFAS and Inventory Development. From GGKP's end, let me extend my deep gratitude for registering and for joining. My name is Anastasia Buchok, and I'm working for GGKP in Global NIP Update project. Today's webinar will introduce the methodology of inventory development for industrial persistent organic pollutants with a special focus on PFAS and short chain and medium chain chlorinated paraffins. These substances represent some and the most prevalent and persistent pollutants. One second. And still being produced and used in massive quantities, especially the SCCPs and MCCPs are being used in massive quantities globally. Around 1 million tons are still produced. These POPs are identified as with the highest levels in human milk, and the levels of PFAS in humans frequently exceed the EU's tolerable weekly intake. Given these concerns, this webinar will highlight the urgent need for robust inventories to understand the major uses and presence of these POPs in products, which is crucial for controlling and reducing their use. And we'll also explore the methodology, inventory methodologies for presumptive PFAS-contaminated sites, sharing knowledge from environmental professionals working on the front lines of the pollution control. And finally, our today's webinar will be conducted in English language, will be recorded. This event is supported by 6 my colleagues who would ensure interpretation into French, into Spanish and Russian languages. Please feel free to select your language in the bottom panel of your screen. There is an icon of the globe, so please feel free to select the language. Once we start, please feel free to introduce yourself in the chat. That's a great opportunity to meet your colleagues. Once again, say hi to everyone. And taking this opportunity, let me remind that our next GGKP webinar will be the day after tomorrow on 19th of September. And it would be dedicated to inventory development of UPOPs, dioxins and furans. So we kindly encourage you to register, and I will share the link with you in the chat very soon. And now let me introduce our today's speakers. This is Dr. Roland Weber. He's engaged in POPs research and consulting for decades and supported a number of countries in development of their NIPs. And our second speaker is Stephanie Corral, a journalist from Le Monde, who is extensively working on Forever Pollution project. This is a very impressive one and would be a great reference for on the experience of mapping of PFAS-contaminated sites in Europe. And I will give floor to our first speaker. The floor is yours, Roland.
Yeah, thank you, Anastasia. Thank you, everybody, for joining our webinar. The webinar will have 3 parts. In the first part, I will introduce to the methodology for developing inventories for new listed industrial POPs. In the second part, we will look to the introduction of the POP PFAS and related inventory development. And in the last part, then on the introduction to the chlorinated paraffins and listed as POPs and their inventory development. So meanwhile, 22 more POPs have been listed between 2009 and 2023. Now we have 34 POPs or POPs groups listed in the Stockholm Convention. And when in 2009 the new POPs were listed, like PFAS or the PBDEs, it was clear that new methodology is needed to develop inventories, because these chemicals are in products or in plastic in products, which make it quite complicated. And for that, a standard methodology was developed, which we are following for all these industrial POPs. And the first presentation is on this standard methodology. So when we look to these 34 POPs, we have meanwhile 3 fluorinated POPs listed: PFOS, PFOA, PFAS, and related compounds. We have short-chain chlorinated paraffins listed since 2017. We have 5 brominated flame retardants, and also in the last 14 years, range of unintentional POPs were listed: chlorinated naphthalines, hexachlorobutadiene, pentachlorobenzene, which will be addressed on Thursday in the webinar. Also, recently, non-halogenated POPs, the first non-halogenated POPs, UV328, has been listed in 2023, and the flame retardant Dechlorine Plus and the pesticide Medoxichlor. Currently, in the POP reviewing committee, we have another fluorinated POPs. These are the long-chain perfluorinated alkylated acids, and also the medium-chain chlorinated paraffins have been evaluated in the POP reviewing committee. In these 2 POP candidates will be probably listed at COP12 in 2025. To develop inventories, over the last 15 years, a range of inventory guidance documents have been developed, but also guidance documents for action plans, guidance documents on alternatives to POPs. And today we will look here to the POP PFAS inventory guidance and to the inventory guidance for short-chain chlorinated paraffins. And in our last webinar, a bit more than a month ago, we have looked to the sectoral POP inventory guidance, where I will say also a few words. So first, to the objective of POP inventories. So POP inventories should provide the basis for prioritization, action plan development, and for deciding on management strategy by determining the quantities of the POPs that are produced, used, stored as stockpiles, and generated as waste in a country. Then strategies by identifying the important economic sectors and operators and the type of actions required for those sectors, estimating the capacities needed for the implementation, and identifying the sources that should be prioritized. So these inventories should also provide a basis for the evaluation if current national use, production, and chemical waste management meet the requirement of the Stockholm Convention and identify areas where it does not. It should provide the basis for Stockholm Convention reporting obligations, mean Article 15, and help to identify gaps for prioritization and action plan within the NIP development, Article 7 of the Convention. Also, it should help to identify the need for financial and technical support. When we look to the industrial POPs, we have still some POPs which are still produced and have exemptions. This include PFOA, short-chain chlorinated paraffins, decabromodiphenyl ether, and UV328. So here the inventory need to assess the entire life cycle of these chemicals. And in my opinion, this is an interesting exercise to understand the gaps of general global chemical management. So also for these industrial POPs, the end of life becomes more and more important because when we think about circular economy, for example, for plastic, there is a big pressure on recycling. And therefore, the POPs, we need really to know where the POPs are and need to separate them, that they are not coming back here by recycling into new products. For the inventory methodology, we have developed a 5-step approach. So step 1 is planning the inventory. Step 2 is choosing the data collection methodologies. Step 3 is then collecting and compiling the data from the key sectors. Step 4 is managing and evaluating the gathered inventory data. And step 5 is preparing the inventory report. First to step 1, here planning the inventory. Normally there is a national inventory team to develop. Then the stakeholders need to be identified. then the scope of the inventory need to be developed, and then work plans can be developed on this basis. For the national inventory team, it's normally a multi-stakeholder inventory team with the necessary competencies and access to relevant inventory information for the different sectors. This team would then comprise normally out of governmental ministries for chemicals and waste management normally, but also it would be good for many activities to have the industry ministry there. Then customs are needed. The private sector is very important for industrial chemicals. NGOs, which can be CSOs, this means civil society organization, but also industrial associations. Then also research, especially those which are working on POPs or resource and waste management or possibly material flows. The next is to identify then the key stakeholders. So for the different sectors, key stakeholders need to be identified, which have access to the necessary information in the different sectors. And depending on the needs and availability, stakeholders could either become part of the inventory team or they just support here with data and information. About objective and scope. So first setting the objectives of the inventory and deciding the scope, considering the national circumstances and, for example, how much time you have and what is the available resources and capacity. Then after the initial assessment, a good scope setting need to be done. And then within the work plan development, the individual sectors need to be developed with inventory strategy to decide on the methodologies to use, the activities needed and the assignments, setting timeframes and milestones, and allocation of the resources of planned activities. And here, Jeff is for the low and middle income countries supporting still the NIP updates. And here at the moment, UNEP has another NIP update. So many of the participants here are in this NIP update work currently. So welcome. And also, I mean, after the presentation, those countries can approach if they have questions. Coming to step 2, choosing the data methodology. Here we have developed a methodology which should allow all countries at least to do initial assessment. So in the initial assessment, it's just mainly about looking to the focal sectors, doing internet searches. You have the inventory guidance, which give useful information. So each country can at least do this kind of tier 1 assessment. But overall, we hope that all the countries for the NIP development come to the tier 2 assessment, which is then already inventory or at least a preliminary inventory. This means data collection from detailed statistics from the different stakeholders, possibly site visits. So here at least already normally a kind of quantification or semi-quantification is possible, and often it gives a reasonable inventory already. Then in-depth inventory, where then, for example, monitoring is done, analysis is done. This is often not possible in countries where there is not a analytical capacity. But also there, I will give some proposals maybe how this might be overcome. Because when we look to the most low and middle income countries, there is a lack of analytical capacity, for example, for PFAS or also for chlorinated paraffins, where the analysis is quite complex. But on the other hand, many POP data are available. For example, we have developed a nice Stockholm Convention guidance on POPs in products and recycling, where we have compiled more than 100 of studies of POPs in products and recycling, where you can look for data which other research groups have brought forward. Also, POPs data are generated by the Global Monitoring Plan from the Stockholm Convention. Next phase of the Global Monitoring Plan is at the moment in current planning. so more data will come up. Then there are options of South-North cooperation. For example, we had a nice study between Germany, Sweden, and Nigeria, generating really good data on PBDEs and other brominated flame retardants in electronics. And there are South-South cooperations. For example, at the moment, there is a China Belt Road POP monitoring projects where data are generated. Then there is a regional approach for organizing POP monitoring. Some laboratories also in Africa have the capacity for brominated dioxins and even for PFAS. Yeah, so also there, maybe it's possible to come to a tier 3 inventory. Also, material substance flow analysis is considered a tier 3 inventory approach. I'm in very big favor of this material substance flow analysis. So we have developed now also for the sectoral inventories, now material substance flow analysis. And this is also here the links on the GGKP inventory here for new POPs in electronics, in end of life and in vehicles, and in buildings and construction. Coming to step 3, collecting and compiling data from the main sector. When we look here, for example, for PBDEs, for hexabromocyclododecan, Decloran Plus, and UV3 to 8 inventory, their main use is in electronics, transport sector, and construction, and in plastics and polymers in construction sector. So this is covered now by our sectoral guidance, where we had a webinar recently. So these POPs can be covered by this sectoral approach, linked to also the POP inventory guidances. And I recommend you to look to this recorded webinar where the link is provided here. When we come to POP PFAS, it becomes more complicated because we have it partly in production. PFOA is used, for example, in textile production or in different productions like semiconductors. Yeah, we have them in firefighting foams. We have different industrial uses like plating. We have them in carpets and furniture. So here, the sectoral approach is not sufficient. We really need an inventory approach of PFAS, which will be then the next presentation. The same is true for chlorinated paraffins. So here you see the overview of the inventory guidance for short-chain chlorinated paraffins, which also can cover medium-chain chlorinated paraffins, which will be listed 2025. So those are still produced in large amounts. Their main use is in plasticizers like PVC, polyurethane, and rubber, but they are also used in a range of industrial processes like lubricants, metalworking fluids, leather, fat liquoring, and so on. So also therefore, the short and medium chain chlorinated paraffin cannot be covered by the sectoral approach. And therefore, the last presentation today is about inventory development for chlorinated paraffins. So for both of those, for PFAS and for chlorinated paraffin, we need to look to the industrial sector, we need to look to the consumer market, we need to look to the professional use areas and to waste management, and especially for PFAS also to contaminated sites. Then the step number 4 is managing and evaluating the data you have gathered. And when you find that these data are not sufficient, then you can go back to step number 2 and again choose maybe another or better methodology and gather more data that finally the evaluation of the data you can conclude, okay, for us it's sufficient that we can make our conclusions about action plans and so on. And then in the managing of the data, the compiled data can be evaluated and validated by presenting it to national stakeholders and experts for getting feedback, for assessment of inventories by external reviewing of the data, by plausibility considerations. So for most of the newly listed POPs, the total historic production and or the current production are known. So for this, you can look to our webinar. We had also a little bit more than a month ago about production, trade, and use, and the related report here. And here, when you then compare your inventory data with these overall productions or yearly productions, you get already an idea if the amount you have inventory is possible, is plausible, or is not plausible. Yeah, for example. Then you can, of course, include measured data from own monitoring efforts or information from other monitoring studies for validation purposes. So here I refer to this monitoring of POPs and products and recycling guidance. Then you can compare the inventories to other countries, yeah, neighboring countries, and see if there is big difference. And then you see if you are better or if the other country was better. And also the material and substance flow analysis can help to validate inventories during the development. Yeah. So also in step 4, you would identify gaps and limitations and measures needed to complete the inventory, to identify if the obligations under the Stockholm Conventions are fulfilled and the necessary actions need to fulfill them. For example, if you find in your inventory that there is a use which is actually not allowed by the Stockholm Convention, then you can put, what you have to do in your action plan. Also to identify the need of notification of the registration of acceptable purposes and specific exemptions under the convention. So if you have found that a certain POP is used in your country, you have not registered yet, but it is allowed as an exemption, yeah, then you do then your notification to the BIS Secretariat and to the COP. And also for this work, we have developed guidance for quality assurance and quality control for inventory data, which have been published, and a webinar will come this year, likely in November. The evaluation will be on the basis for updating the NIP and development of action plans. So the gaps and limitations you have found might also trigger necessary actions that, for example, you update the inventory, improve the inventory, and so on. So all these go into the action plans, and they can then be necessary for applying for funds from GEF or from a bilateral donor. One slide about data management, database organization. So what data management and database are useful for the compilation of new POPs inventories and information, and how to store that information. So here, POPs should not be addressed on their own, but should be integrated within a country chemical management and waste management schemes as much as possible. Information on POPs should be integrated into generated and from existing databases and information. It is recommended here from UNEP that the National Statistical Office should, if possible, manage relevant data which are needed to generate the POP data, but also maybe the POP data. So for this, also from UNEP side, we have developed a guiding methodology for strengthening the collaboration with national statistical offices to address gaps related to POP data. And also for this, there will be a webinar upcoming. So following databases are considered. So first, POP as a chemical, so possibly included in chemical databases or impulse to develop a chemical database. There are some UNITAR activities in respect to chemical databases. Then certain industrial and unintentional POP links to pollutant release transfer register. So here, this kind of information could be integrated in the PRTRs, or you might find it in the PRTRs if you have a good one in your country. Then important databases, waste. Here, POP waste should be integrated in the general waste catalog. You should know in your waste catalog in which waste categories you have your POPs, where you can find it. And you can introduce it to waste databases. And very important, last not least, the POP contaminated site should be integrated in the general database of contaminated sites in your country. And if you don't have a database on contaminated sites, the POP inventory activities could start to kickstart such a database on contaminated sites in your country. Finally, inventory report will be prepared. So this is then the final step for each POP inventory sector. This inventory report is aimed at supporting the development and formulation of the NIP. The inventory report should also serve as a basis for Article 15 reporting. And there is now, you know the tables for your Article 15 reporting, and these tables are now also integrated in the UNEP new NIP template that the Article 7 NIP development and the Article 15 reporting is brought together. So furthermore, the inventory reports can be the basis for the development of NIP projects, developing effective strategies and action plans for managing the POPs in order to meet the obligations of the Stockholm Convention. So that was the first overview presentation on the general development of industrial NIPs. And now we come to the second presentation. This is just the practical applied methodology to the inventory development for the fluorinated POPs, PFAS, PFOA, PFAS, and related compounds. So here you see the structure of PFAS, PFOA, and a little bit shorter PFAS, which have been listed here recently, 2022. And as I mentioned, now the long chain perfluorocarboxylic acids from C9 to C21 have been evaluated by the POP reviewing committee and will be listed in May 2025 by the Conference of Parties. And this will kind of complete the first, let's say, big part of bioaccumulating PFAS, which is quite a big task. And these POP PFAS are only a small part of the large PFAS universe, which need to be controlled. So PFAS and PFOA has been listed. They are now phased out, but at the same time, industry often substituted these long chain PFAS with the so-called shorter chain PFAS. And also with PFAS ethers. Ethers means that within this carbon bond, you have some oxygen inserted. So this results in a huge zoo of PFAS chemicals. The OECD has tried to develop a list and concluded that there are around 4,700 of these PFASs. The European Chemical Agency has developed a restriction proposal, and in this restriction proposal, they are proposing to restrict more than 10,000 PFASs. Yeah, so you see the complexity of this chemical group. So PFASs are highly persistent. They are so-called, therefore, the forever chemicals. The perfluorinated PFAS do not degrade in soil or groundwater. Yeah, so if you contaminate your groundwater, this contamination might be there in thousands of years or 10,000s of years if they don't move. Many of them are mobile and can contaminate the groundwater and the drinking water. Then the POP PFASs are bioaccumulative in humans and bind to proteins, which are actually our working horses. They have a wide range of toxicities, including cancer, developmental delay, impact on sperms, impact on immunotox, and endocrine disruption. And the exposure to POP PFAS exceeds today frequently tolerable weekly intake, which have been set, for example, by the European Food Safety Agency. We start with PFAS. So the major production and use was from 1980 to 2002, but already in the 1960s and 50s, some PFAS have been produced but the big production, you see here the strong increase in the 1970s. And what you see here is abrupt decrease in production here in 2000, 2002, where 3M, which was the major producer, phased out production with a peak production around 4,500 tons a year. So in total, 96,000 tons roughly of PFAS have been produced, estimated here in this review article. And what you see is that the largest part of this have been used until 2000. So afterwards, China continued the production, but only at a capacity of around 100 to 200 tons a year. Yeah, means maybe 5% of the production before from 3M. This also means that the largest share of PFAS already entered end of life, landfills, environment, including contaminated sites, because only a minor share has been destroyed in the past in waste incinerators in a few countries. So, and the share of this is still today in stocks, especially, for example, in carpets, which very long service life. The same is true also for P4 and PFAS and related compounds. So here the major production was also before 2017, also with major productions here in the 1980s, 1990s. Yeah. So therefore, today in the inventory, we will very much look also to the production and use, but the big part of it is also waste management, landfill challenges, and contaminated sites. So a good news is that the production of PFAS likely stopped in 2022, also in China. So today there is no production known, also production is still allowed. For more details on production, use and trade, you can look to our webinar, which we had a bit more than a month ago. So the listing of PFAS was PFAS-F, PFAS and the salts. And the PFAS-F has been listed at that time because from the PFAS-F chemical, all other PFAS-related compounds were formed. Yeah, and the OECD estimates that we have around 165 PFAS-related chemicals. Yeah, one of it is, for example, here the adfose, yeah, where you have here this amide, and this you can, for example, link to a polymer. Yeah, like to a carpet or to a textile. And then these precursors, these PFAS precursors, then can degrade again and can generate again PFAS. Yeah. So therefore, also by the listing of PFAS, the idea was to also restrict all other PFAS-related substances, similar what has been done with P4 and PFAS. So when PFAS has been listed in 2009, it was listed in Annex B because it was considered so important industrial chemical that there were some uses which were needed and listed as acceptable purposes. And in addition, also a range of specific exemptions have been listed. So here you see the list of acceptable purposes. In the beginning, the list was quite long. As you see today, the only acceptable purpose still listed is the insect bites with sulfuramide as active ingredient to control leaf cutting ants. None other use is considered an acceptable purpose. Also, in the beginning, in 2009, a long list of specific exemptions where alternatives need to be phased out normally within 5 years have been listed. And as you see here, a range of these uses have already stopped. Yeah, so you see here really the conference at work that there is then an evaluation after some time if it's still needed. And if it's not needed, for example, here for carpet, paper, and textiles, the use was already then stopped, I think here with the decision Stockholm Convention 7.1. And more exemptions have been stopped with Stockholm Convention decision 9.1 and 9.4. And today we have only as a acceptable, as a specific exemption, hard metal plating in closed loop system and firefighting foams for liquid fires. Coming to the P4, here the production was overall higher than for PFAS. Between 1950s and 2020, about 9,500 tons of P4 and AP4, this is the amide, the ammonium salt of P4, and 171,000 tons of PFAI, which is the iodide compound, and is used to produce P4-related substances, including the fluorinated polymers. So also P4 and P4-related compounds are still produced. And the related compounds include also the salts and any substances that can degrade to P4, which are all those which have a linear or branched perfluoroheptyl group with the moiety of C7F15 as one of the structural elements. And the POP reviewing committee have compiled a list of all these alternative chemicals, which are more than 300, yeah, including the related CAS numbers. So here, the POP reviewing committee is this month, and here you can find a document with all these related substances. So I just introduce you one here. This is the A2-fluorotelomere alcohol, A2-FTOH, which can degrade by oxidation, partly here to P4. Here in this study of Just et al., they found that in the degradation here, around 21% has been formed. In other studies with other degradation frames, then only 6% of P4 has been formed. So this is flexible, but the degradation of this A2-FTOH are generating this P4. P4 has been listed in 2019 in Annex A, allowed with specific exemptions for production and use. So here is the list of the exemptions. So this includes also firefighting foam, but only the existing stocks, so no new production. Textile for oil and water repellency, photolithography, photographic coatings, invasive implementable medical devices, manufacturing of fluorinated polymers, of different fluorinated plastic accessories for car interior parts and for electric wiring. Then the third group of PFASs listed in the convention are PFAS. Yeah, you see here with the 6 carbons and the sulfonate group. So here the production also stopped in 2022 in China. There is currently no production known, and it's also not allowed. Overall, the production was lower, around 10% of PFAS, but not so detailed data on the PFAS. The same like for P4, there are also these related substances. So here the chemical moiety is the C6F13SO2 that can potentially degrade to PFAS. And here also for this related substances, the POP reviewing committee compiled the indicative list. And this is also in this POP reviewing committee meeting updated here in the INF 13 document. So production, no exemption in the listing, and also total ban, no use exemption. So coming now to the inventory. The objective of the inventory for PFAS, P4, and PFAS is to identify the current production and use of PFAS and P4 in the different use categories listed as acceptable purpose or specific exemption in the Stockholm Convention, and also an assessment if it's used in non-exempted uses. Then for PFAS has no exemptions and production stopped, but it can still be present as impurity in PFAS. So PFAS was normally as impurity between 4% to 15% in PFAS, and the PFBS, the butyric sulfonate, which is still produced, might also contain some PFXs. I have not seen data on that. If anybody knows, maybe he can put a comment in the chat, which is still produced at high levels. So then to look to the stockpiles of PFAS, P4, and PFXs containing products in use and the related waste. I mentioned already the carpets. To identify contaminated sites and their risk, to identify gaps, and if the current status meets the requirement of the convention, and where it does not. So what are financial needs in your assessment? What could be possible projects on PFAS? To give inputs for developing a strategy on PFAS and P4 phase out and management, if you are still using it in one of the exemptions, and developing of action plans and prioritization of the sectors and actions that need attention. Finally, to provide the basis for reporting obligation, Article 15 of the Stockholm Convention, and to develop the NIP. So also here, we have developed guidance, and now in this guidance, all 3 PFAS groups, POP PFAS groups are included. And there you have the background information, the listing information. And here in chapter 3, you have the information on the relevant chemicals here, about the production, about the different main uses, import, export, about stockpiles, wastes, and contaminated sites. And in this presentation, we will look to it in the way which is proposed from our industrial inventory approach. So here the 5-step approach applies. Now we look to step 1, planning the inventory, and here to the national inventory team. So here you should look for a multi-stakeholder inventory team with the necessary competence and access to relevant information for the different PFAS inventory sectors. The team would comprise of governmental ministries in chemicals and waste management, but also I would recommend that the ministry responsible for water is included, and also the Ministry of Industries, especially if you are still using it. We need the customs, we need the private sectors which are using or even producing it. The firefighters are important, and again, NGOs working here on POPs, either from industrial associations or from the civil society organizations and research organizations which are working here on PFAS-related topics and water and waste management, and those which are working on contaminated sites. Then step 2 is identification of all key stakeholders. Here they can be identified by web search, national registers, which have access to the necessary information in the different sectors, and I will introduce to the different sectors. Depending on the needs and availability, stakeholders could here become part of the inventory teams if they like to be member, or they just support with data and information if you want to keep it neat. Objective and scope, the objective and important elements of the inventory. So here first you do initial assessment, and from this initial assessment, you form the scope, considering your circumstances and the available resources and capacity. Then you develop the work plan. So for this, you already need to know here the major sectors, the industry sectors, the professional use areas, the consumer markets, the related waste, the stockpiles, and the contaminated sites. And we will now, in this presentation, go through the details. Also here, you have to decide then in step 2, what kind of inventory tier you are aiming for. If you only have a relatively short time and resources, and what is your analytical capacity, you would choose the related tier you aim for. And then you would start to collect and compile the data of the individual sectors. And the the following type of data are needed and should be collected for the inventory: the quantities of PFAS and PFOA and also PFAS from the stockpiles, and related compounds used in industrial processes, professional uses, and use in consumer products. And you see here I have put PFAS in brackets because it is not considered that it is used in industrial processes and professional uses because production has stopped. Yeah, but it might be impurity here, for example, for PFAS. Yeah, so therefore, still you can look for it also when you analyze different processes. Then to look for releases of PFAS from industrial and other point sources, for example, for the use of firefighting foams, or for example, the release from a plating plant, which is using PFAS. Then to the quantities of PFAS, PFOA, and PFAS in waste and in stockpiles, and the presence and situation of contaminated sites. The methodology approach can also use estimates and qualitative indicative surveys, because often you will not get quantitative data. Yeah, so here expert judgment can be very important to do a semi-quantitative estimate. Yeah, but this kind of estimates and so on, you would mention when you write the inventory report, that afterwards for the project, it's clear that this is an estimate and maybe not, you should not put a $1 million project on that if the data are not robust enough. So here, then step 3, data collection, starting with the desk study of existing information. Here, major publications first to look to the inventory guidance, where good information has been compiled in POP reviewing committee documents. We have other Stockholm Convention guidance documents. One is, I mentioned, the screening, monitoring new POPs in products, but also the sectoral guidance. Other published literature in scientific journals. Actually, the last 20 years, tens thousands of publications about PFAS have been published. But of course, it's quite difficult to get through of the jungle. Yeah, but there are also recently very good review articles. So therefore, also scientific journals articles are useful. Then technical reports, research reports. Then there's big information and knowledge at organizations, especially at industrial organizations, which need to be involved if sectors are there in the country. Customs, then the National Statistical Office. And you can do your internet search today. Then data collection with questionnaires. 10 questionnaires for the major use have been developed to gather information from key sectors, and these questionnaires are included in the POP PFAS inventory guidance. Yeah, so here for the questionnaires, you need, of course, first to develop your list to whom you want to contact. Then possibly you could do consultation meetings with stakeholder groups where you explain what and why. And then on the outreach mechanism, you can already use these consultation meetings, of course. Otherwise, if you are in a larger countries and you have, for example, 5,000 plating industries in your country, then maybe you cannot invite everybody. Yeah, then probably you have to think on postal distribution, or what can be very useful, supply chain distribution. Yeah, that you go to the Association of Platers and meet with them, and then encourage them to do this distribution and gather the data from their industries. You can use trade unions, NGOs, local governments. If you are a smaller country, yeah, then and you have just 2 or 3 plating companies, or let's say 5 firefighting organizations which you need to get information, then you can do a hand delivery. Yes, that's always the best if you go and if you can go to a stakeholder and directly discuss with him, take the questionnaire and directly then ask the questions of the questionnaire. In selected cases, site inspections might be needed. So, for example, if for specific PFAS, PFOA use areas like the firefighting foams, the technical declarations, for example, in the material is unclear, then sampling and analysis might be needed, yeah, to be done. Material substance. So here, a guidance has been recently developed by Thailand for the assessment of firefighting foams and for sampling and analysis of PFAS, PFOA, and PFAS in firefighting foams, together with UNIDO and in a CHEF project. This is not published. I have asked if it can be published. I like the guidance. I needed to comment it, and I hope that this could also be used then by other countries. So here, coming to some practical considerations for key areas of PFAS inventory development. First, here to the assessment of imports and exports of PFASs. So the control of imports of POPs is the first line of defense. This is a quote from Rainer Arndt, who was for long years the chair of the POP Reviewing Committee. Information on current and historic imports and exports of PFASs could be available from custom service from related industries and industrial associations, including the related users. PFAS and PFOA related compounds are listed in Annex 3 of the Rotterdam Convention, and actually they are subjected to prior informed consent procedures. I would be also interested, and maybe you can put it in the chat, if any of you have ever conducted a PIC procedure for PFAS and PFOA. PFAS, some of its salt and related compounds have assigned specific HS codes. So HS codes are used on imports and export declarations, which can be used to seek necessary information for the inventory. So CAS numbers and trade names should also be used to find the import and export information. And CAS numbers are compiled here in the POP Reviewing Committee documents on related compounds, where you can look for them in the import, but also on company levels or in sales in the market. So for more details on trade of POPs and PFAS, see also the related guidance and webinar from a bit more than a month ago. Now we look first to the professional use areas, because that's relevant for many of the countries which are listening. So also when we talk about professional use areas, we have to think about stockpiles and waste from these professional use areas, and also contaminated sites of these professional use areas. Very important for most countries are firefighting foams and the inventory of firefighting foams. So here, especially aqueous film forming foams, AFFF, are used for Class B fires. These are flammable liquids like oil, petrol, other non-water soluble hydrocarbons. So they are at facilities where larger quantities of these flammable liquids are stored, for example, at airports, oil production, refineries, oil storages, and so on. So they are present in fixed installations sometimes, and sometimes not in fixed installations. Then they are available at firefighting services, and a share of it, even in fire extinguishers, can even be present at private level, yeah, or in schools. For example, in Suriname, we have found fire extinguishers containing PFAS in schools and universities. So here, step one, preliminary survey to identify the relevant sectors that can be professional users of firefighting foams containing PFAS. Do a preliminary contact with listed stakeholders by phone or visits. Custom services and firefighting foam distributors can be valuable source for the information. And then it's recommended to do a stakeholder meeting. So here, with the purpose that the stakeholders better understand the intention of the inventory among the stakeholders, and getting back to make the survey as adequate and practical as possible and targeting the right areas. So data collection for the firefighting foam to get more in-depth information on stockpiled firefighting foam, the consumption on the firefighting foam in fire drills or accidental fires, and waste management of firefighting foam which has been expired would be compiled. In this assessment, also information on location of firefighting drills and location of former fires where these specific PFAS-containing foams were used in the past 40 years. So these can be considered presumed PFAS-contaminated sites. So also here, this you can do in the discussion here with the stakeholders, or also included in the questionnaires. For some of the firefighting foams, it is known what type of firefighting foam is containing what type of POP. Yeah, so here is a list from the European Chemical Agency from 2020, but I need to highlight that this might also change over time, and maybe today a firefighting foam with that name might not contain that POP anymore. So here you can check the material safety data sheet, MSDS. Further investigations, so identify national supply chain for the firefighting foams. You can check if there are also alternatives, fluorinated foams or alternative non-fluorinated foams for substitution. And then you can look for in-depth information on these PFAS-contaminated sites by the former use of the foams. Then data management in the evaluation. Here you would calculate the total amount of PFAS in the foams, the quantity of the different firefighting foams, and in what type of uses they are still, or how many of these are in end of life and need to be destroyed. For this, you have developed a work plan. Yeah, so that's just an example for a work plan here from Norway for developing an inventory of firefighting foams. Here, the first month, the planning of the inventory. The second stage, the identification and initial assessment also takes about 1 month. And then around 3 months for gathering here the information, doing the data collection and the more in-depth analysis. Could roughly take 5 months, depend on the size of the country. Finally, 1 month for data management and reporting. Similar approach of the work plan and developing inventories can be done for the other inventory areas. They might be simpler because might be less complex. So therefore, for the others, I don't do this detail. So you just follow, let's say, the methodology I have introduced to you with the firefighting foam. So here, and therefore for the others, I make it short. Otherwise, we would have 5 hours. So when you also would look for the inventory for PFAS use in electroplating, it's still allowed. So PFAS-related chemicals have been used as surfactants and wetting agents and mist suppressants here in hard and even decorative chromium plating. The hard chromium plating is still exempted. So here you would look for the different amount of these chemicals used in your plating industry. And when you have the total amount of the chemicals and you know the concentration of the PFAS, then what the inventory would like, and the same is true for the firefighting foam, that you really calculate not only the total amount of foam or here the total amount of chemical present in your plating industry, but also what is the total quantity of PFAS in these chemical. Yeah, so this you can calculate, for example, by the total amount of the chemical used in plating multiplied just by the percentage of PFAS. Yeah, it's a simple calculation, but it's an important calculation because afterwards you are interested what is the real concentration of the PFAS in your specific applications, that you can do a prioritization and maybe then also can do a project. Also, you would look here to the alternatives. A major alternative which is used here is the 6,2-FTS. This is similar like PFAS, but here at these 2 carbons, 4 fluorines have been substituted by hydrogens. And here, this is another alternative used, for example, in China, the F53, an ether. But this have been found bioaccumulative and also toxic, and it's a real regrettable substitute. Then another important use still allowed is the inventory of PFAS as pesticide, especially the insecticide for the ants, so for the leaf-cutting ants. So here it is still marketed in South America, especially in Brazil, in surrounding. But for example, also when we did our inventory for Suriname, we found imports of PFAS, of sulfuramide, and the name was called Mirex S. Yeah, so you can look here. We have published the PFAS inventory of Suriname, where we have described on this inventory development, and also what kind of alternatives are used. So one alternative which is used today frequently is fipronil. But fipronil is a highly hazardous pesticide in the Pesticide Action Network list. So therefore, it may be also a regrettable substitute. In respect to pesticides, there is another assessment which is relevant for inventory, and this is the assessment of PFAS-contaminated fluorinated pesticide containers. The US EPA testing showed PFAS contamination from fluorinated high-density polyethylene, HDPE, pesticide containers, and similar plastics, other fluorinated polyolefins. And here they found PFAS in these containers and a PFAS contamination of the pesticide up to 250 nanogram per gram. So by this unintentionally produced PFAS and other PFAS, it's not only PFAS, these PFAS and PFAS are spread to agricultural area with risk to transfer to food crops, vegetables and fruits. So therefore in 2022, US EPA provided information to manufacturers, processors and distributors. In 2023, EPA issued an order to a company producing these containers not to unintentionally produce PFAS chemicals in the production of its fluorinated plastic containers. And in 2024, February, EPA released a new method for analysis, of 32 PFAS, including PFOA, in these containers at down to 2 ppt. So if you don't know what kind of containers your country is using for the pesticides, these containers are used, can be used, might be used also in your country. So here you have a methodology to analyze them. So therefore, the assessment of the use of fluorinated and other high-density polyethylene and other polyolefin containers in the countries would be done, including PFAS monitoring. So also PFOA and PFAS were used as inert surfactants in pesticide products, but this use is not exempted. Then another inventory area is PFOA in electronic and semiconductor production. So here PFOA and related compounds can be found in the semiconductor industry. They are contained in equipment used to manufacture semiconductor and are used in the photolithography and etching processes during semiconductor use. So this overall use is considered moderate, total only around 50 kilogram per year, and releases are considered less than 4 kilogram per year. So here, assessment of companies producing semiconductors and related use of PFOA, past use and release of these compounds, and the related alternatives would be done. Then for medical devices, PFAS and related compounds have been used in vitro diagnostics, medical devices such as video endoscopes and CCD color filters, but that was only around 200,000 filled endoscopes and only 150 nanograms. So in total, this was 0.03 gram. So therefore, it's absolutely not relevant, and you do not need to do an inventory on that. The same for implementable medical devices. Here, the PFOA is kind of an unintentional trace in PTFE, polytetrafluoroethylene. And also here, it is estimated that the total European market contain around 20 gram PFOA in this material, and extrapolated to around 100 gram totally in the world. So also this is not really something for inventory, but this is rather a part of the overall PTFE and fluoropolymer management. Then we have the use of PFOA and photographic coatings applied to films. So here, PFOA still play an essential role in manufacturing performance of certain imaging products, providing surfactants and friction control and dirt repellent qualities. These substances also provide important critical antistatic properties and therefore safety features by controlling the buildup and discharge of static electricity. Moreover, PFOA-related compounds are considered necessary for the application of coatings layers during the manufacture of some remaining conventional photographic films products. So here the inventory would be the assessment if these technologies are still used in the country, but overall they are getting less and less because there is a continuous transition towards digital photography. Looking to the consumer market, here, especially to textiles, carpet, upholstery, also there, it's not only the consumer market, but also the stockpiles, waste, and contaminated sites. Important use of PFOA is in textiles, so they are still used for oil, water, and chemical repellent finishes of textiles, especially the PFOA precursors A2FTOH I have shown you is still used. Also, there might be still some textile furniture where PFAS has been used, but PFAS has been used mainly before 2002 and maybe minor use until 2012. So here, when you look to the market, there are a range of measurements here of textiles, which are also included in the inventory report. Here, especially surface treating textiles in automotive, aviation industry, sports, outdoor clothing, home textiles, carpets, sun protection in professional sectors like medical, firefighters, and military. And here, PFOA is often and PFOA-related compounds in side chain fluorinated polymers. The same is true for carpets. Carpets was a big use here for PFAS until 2002 and maybe possibly until 2012. Also PFOA and PFAS might have been used. Carpets are especially relevant because they have a long service life. So even maybe a carpet which have been produced in 2000 might still be in use. And what we have found in Suriname was that even the shelf life here in Suriname of carpets have sometimes be more than 10 years. Yeah, and there we have done an assessment with the so-called drop test. So here for PFAS treated textiles or carpets, there is a drop test where you can easily test without, let's say, instrumental analysis if such a textile might contain PFAS, just where you look to the water or oil drop and the angle. Yeah, when you have a repellency, then and a high repellency more than 90 degrees, normally it can be considered a PFAS. But of course, it's not clear if it's PFAS or PFOA or another PFAS. There you need instrumental analysis. So this use in carpets and textiles and also paper was more than 50% of all PFAS. Yeah, here what you see is a kind of material flow, substance flow from 3M in 1997. And here you see that this is also in the inventory guidance. I don't go into details, but what you see is that more than 50% was going into carpets, textiles, and paper, and less than 1.1% was going into firefighting foams. Yeah. So you see how relevant this textile, carpet, and also the paper is. So here to the paper, paper, especially in part for grease and oil water resistance, has been used since the 1960s. Long chain PFAS have been used, including PFOS and PFOA related substances, but they only had exemptions until 2012, and today mainly there's no exemption, and mainly C6 PFASs are used. Yeah, these are mainly in disposable plates, food containers, baking paper, popcorn wraps, pizza boxes, and so on. Just want to highlight this study from the European market, where IPAN and related NGOs did a screening and found that 32 out of 42 fast food packaging they tested contained PFASs, including Kentucky Fried Chicken, McDonald's, Dunkin' Donuts, and Subway. And McDonald's was interesting. The French fries packaging in the Czech Republic contained PFAS, but in Denmark it didn't contain PFAS. Yeah, and interesting because Denmark restricted PFAS in food packaging in June 2020. So you see there are alternatives. You only need to make the right regulations. And McDonald's announced to phase out PFAS in their food packaging by 2025. There is an impact on paper recycling. Yeah, so this PFOA, PFAS come back, but PFOS only has been maybe already phased out 12 years ago and might already be gone through the recycling. What I like, and this is the end, let's say, of this bigger part of inventory assessment, is this material substance flow analysis here from Switzerland, where you see major uses. Stock was still in firefighting foam and in service life, like in carpets, yeah, but also a large amount was in landfills. Also, Swiss has a large incineration capacity. So today, when you will make your PFAS inventory, I would guess that the largest part is in landfills. Yeah. So relevant, we will see later on, especially for releases to water and in respect to contaminated site. The last source area is PFAS industry, which is probably not relevant for most of the countries here. PFAS production, fluoropolymer production. Also, this is related to stockpiles, waste, and contaminated sites. So here, production and trade for PFOS, PFOA has been introduced here in the webinar in July. When we look to production, PFAS is not relevant anymore, but PFOA is still produced. So if in your country PFOA is produced, then very important to look to that site. Also important would be what kind of uses would be produced and sent the PFOA and PFOA related substances. This is the last kind of inventory what I have found for fluorotelomers. So it was estimated that about 36% is going to textiles. Today, 30% to firefighting foams, food packaging, 13%, other repellent coating. Yeah. So, but the share of PFOA in this fluorotelomer was not known in this publication. So the use of PFOA in pharmaceutical application is small. It was basically especially reported here from Japan that they are using it in the production of pharmaceuticals. And at the moment, possibly Japan is the only country. You can do assessment in your country, but also here, this inventory activity is considered not too relevant. The use of PFOA and fluoropolymer was very big. The fluoropolymer production was the predominant global use of PFOA as processing aid. Until 2000, 85% of global use of PFOA was in fluoropolymer manufacturing, and we have received, or the Stockholm Convention have granted here exemptions for a range of production. So if you have this production in your country, you would do assessment of the use today. And another important assessment here is contaminated sites, because this use in the fluoropolymers have generated huge contaminated sites. Most known is here Parkersburg in USA, where DuPont manufactured Teflon since 1951 and have contaminated here the city and the Ohio related valley. So there was a large investigation, and DuPont had to pay, and Chemours had to pay more than 670 million US dollar in total. There's also a film I would recommend to look at, and the second film, The Devil We Know, is in the internet you can look at. Similar contaminated sites from fluoropolymer production have been found in China, in Germany, and in the Netherlands. So always when you have such productions, it's also contaminated sites which need to be assessed in the inventory. And with this, we come to the last part of the PFAS-PFOA inventory. These are contaminated sites, which is a huge topic. And here I would like to hand over to Stephanie Horel. I hope that Stephanie is here. She's a journalist from the Le Monde, and she was the person which organized the Forever Pollution project and the mapping of PFAS pollution in Europe. Stephanie, are you there?
Yes, I'm here. Can you hear me?
Yes, I can hear you.
Okay. I put the camera on, so I don't know if you can also see me.
Yeah. And you can just say when I go to the next slide.
Okay. Well, thank you very much, Roland, and good afternoon or good morning to everyone. Thank you for inviting me to this seminar. So I'm going to explain to you how we did this map last year, published in February 2023. Next slide, please, Roland. And so we published this interactive map on the website of Le Monde and also several other outlets. So we can see it as a map of contamination, but also as an inventory of PFAS pollution across Europe. Well, you've seen Roland's presentation, so you don't need me to tell you again that PFAS are extremely persistent, and that major risks at PFAS-contaminated sites stem frequently from PFAS. And I'm going to explain to you how we built this map with the different levels of information: known contamination, known PFAS user, and presumptive contamination. Next slide, please. It's just shortly to explain, we worked as a group. So it was a collaborative effort, what we called cross-border investigations. So if you probably all have heard about the Panama Papers investigation by the International Consortium of Investigative Journalists, but there are other ways to do this kind of investigations. And I'm developing this kind of smaller scale, but more specialized on the environmental issues kind of investigation. So these are all the partners that participated to this project. Next slide, please. And so how we started this investigation is because I was working with a Dutch journalist, and in the Netherlands, they have this problem that has been revealed by the press actually in 2015 about this DuPont, now Chemours, PFAS manufacturing facility in Dordrecht, which has resulted in a huge contamination of the environment. And so he reached out to say, well, I'm aware there's a PFAS facility in France, and there are maybe some in Germany. How many of these facilities exist in Europe? So this was how we started investigating. Next slide, please. And so when we started working on this, we stumbled on this map that was done in the US as an inventory of contamination with two levels. One is the known contamination level, which is data, it's sites where there is contamination data, so monitoring data with actual levels of PFAS in the environment. And a second level of information, which I didn't know at that time, I was a beginner in PFAS, which is presumptive contamination. And I will explain later what presumptive contamination is more precisely, because that's maybe your main interest. But the idea was, let's try to adapt this map to Europe and adapt the methodology that the scientists used in the US. Next slide, please. And so to do this, because we are only journalists, we had to rely on the expertise of 7 what we called expert reviewers. It's a new way to do journalism, is to rely on some scientists. It's not that they are doing the work instead of us, but whenever we had important decisions to make and we didn't have enough scientific background to make the right decision ourselves, we would turn to those people who were sociologists, environmental scientists, or Greta Godelman, who's an environmental lawyer. Next slide, please. So this is about the background of the beginning of the investigation. The main document, even if it's a lot about the cases that are known in Europe, I would highly recommend to read this report. It was like our Bible. It provides a really broad understanding and in-depth understanding of what is PFAS contamination. And so it was published in 2019, and there was this table listing 12 PFAS manufacturing facilities, and a footnote saying that the authors thought there might be between 12 and 20 plants across Europe. So we thought, okay, we need to find the 8 remaining plants. Next slide, please. So to do this, we used like investigative methods, like what journalists do, and some of these methodologies are not widely known in the academic world. So they are called OSINT methodologies. So that means open source intelligence. It's a very pretentious word to say whatever you can find on the internet. We also use freedom of information requests and extreme persistence, pun intended. And so I'm not going to go into the details. If you have precise questions about these methods, I can answer later. But the main source was to look into annual reports of the companies, Google Maps, and to file scientific papers, of course, and to file requests to the authorities. Next slide, please. So in the end, after a month of work, we finally managed to locate 20 PFAS manufacturing facilities across Europe, 6 in Germany, 5 in France, 3 in the UK, and the rest in 5 other countries. 3 of those facilities are no longer running, but it doesn't mean that, of course, the contamination has stopped, because the legacy contamination is still there. Next slide, please. So on the first level of information, known contamination, we updated recently the figure. When we published, we had only 17,000. So now we are getting closer to 23,000 known contamination sites across Europe. And we had this difficulty of, as journalists, to say, like, there are 23,000 contaminated sites across Europe is very scary for the readers. So we tried to kind of rationalize this through the angle of calculating how much hotspot clusters there were. And the number is, even though we tried to do this, the number is still very, very high compared to the reality, or very underestimated. We don't have any means to know today, because a lot of data is missing. But what is important to understand is that we didn't know what was a high value, what is a dangerous level. And so we turned to our experts and we asked them to decide to tell us what they would think would require public action. And they all agreed that 100 nanograms per liter was the threshold to qualify a place like a hotspot. And just to have a benchmark for that, 100 nanograms per liter is the EU limit value in the water directive for only 20 PFAS. So it means, well, of course, it can be discussed, but what it means is that the EU limits are much too high in terms of public health. Next slide, please. Then the following level of information and investigation for us was this idea of presumptive contamination site. So the definition of that is the American definition that we adapted is sites without sampling results, but presumed to be contaminated based on scientific studies and expert advice. So it's not like, we think there might be some use of PFAS in this place. It's because for each place, like for industrial sites, there would be evidence of that this type of activity would use PFAS in at least 4 different reliable sources, and that for this use, there would be evidence of emissions in the environment in at least 4 different reliable sources. So it's a very strong evidence-based approach. Next slide, please, Roland. And so there are 3 different types of presumptive contamination sites. First are places where firefighting foams were used. Second are sites related to PFAS-containing waste. And the third are industrial sites. Next slide, please. So the first one, fluorinated aqueous forming foam discharge sites, are military sites because of the trainings that are made on the military bases with firefighting foams. Airports that are where incidents happened and where you have trainings also. Firefighting training sites, which can be a simple fire station sometimes. And we have figures only for 2 countries and 1 region, because it's the only countries in Europe who have done the work, the inventory. And the bigger figure comes from firefighting incidents, because the inventory was done in Sweden. So a firefighting incident can be like a plastics manufacturing facility in fire, and you have to use this type of AFFF foams that would contaminate the environment. So the majority of the sites we have found as presumptive contamination sites are due to the use of firefighting foams. Then the second type are sites related to PFAS-containing waste. So we chose to like everything was adapted from the American methodology. We chose the largest wastewater treatment plants, so that treating over 3,700 cubic meters a day. So every treatment plant would be considered as presumptively contaminated. And then also waste management sites, which includes landfills for non-hazardous and hazardous waste, but also incinerators. Next slide, please. Then, of course, one of the, well, maybe not, of course, but the trickiest part was to locate the industrial sites. So in the US, what they have done is they have identified through this like double 4 sources evidence approach, they have listed a type of industrial activities that are documented as using and emitting PFAS in the environment, and they listed them using what they call the NAICS codes. That's the nomenclature of economic activity. The problem is we also have this type of nomenclature in Europe, but they are not the same, and it's not. The description are not the same. So we cross-matched the US and the EU nomenclatures. But then once we had done this, we had another problem, is that in the US, when you have a geolocation of all the different activities, but we don't have that in Europe. and I believe it is the case in many countries across the world, that you wouldn't have a centralized database containing geolocation. So what we used was the Register of Industrial Emissions that is centralized by the European Environmental Agency. It only collects data from the largest facilities in Europe, but it was better than nothing. And the description of the industrial activity is much more precise in this register than in the NAICS codes. So by cross-matching again with another database, we managed to locate more presumptive sites. Next slide, please. And so 3,000 industrial sites across Europe, which is like, I mean, as I explained with the methodology, we know it is largely underestimated. There should be many, many more. And the fact that manufacture of paper, so paper mills come first, treatment of metal, we don't know if it means anything. I'm aware that there was a study based on the US map recently. It's not been published yet, but what comes first as the source of contamination in terms of industrial sites is the metal treatment, which is interesting. And so again, it's largely underestimated. Next slide, please. And so in total, for these presumptive contamination sites, we reached the figure of 21,000 sites, which is probably, I don't know how much bigger, because in Denmark, they have recently done this inventory, and they get 15,000 just in Denmark. And Denmark is not a very industrialized country. It's mainly agricultural lands. So it means that in countries like France or Germany, we are probably approaching the figure of 100,000 sites that are presumptively contaminated, mainly through industrial activity and firefighting foams, I think. Next slide, please. And then this is the last bit of knowledge that we could generate from this investigation. So in the course of our research, we had sites for which we didn't have any monitoring data in the environment, but we had more evidence than just presumption of contamination, because, for example, there was a facility explaining on its website, we do manufacture fluoropolymers, not the synthesis, but they are like customizing fluoropolymers for their customers, like manufacturing pipes or ceilings or this kind of things for aerospace or this kind of sectors. And so we had, and they would say, we use the PTFE of 3M in this facility. So we thought it would be useful not to lose this information. And so with the help of the American researchers, we created this new category of PFAS known users. And we managed to locate 231 of them. And what was nice in this experience of exchanging with the experts is that it was a win-win thing. So we benefited from their knowledge, but we gave them back, and this PFAS known users category is being adapted to the US map that I've shown you earlier today. Next slide, please. And to conclude, so at the end of this this adventure, in terms of journalism and science, we published our methodology in the peer-reviewed journal Environmental Science and Technology. So every single detail of how we did this can be replicated and adapted. Of course, there are specificities according to various continents, but it's not that difficult to figure out a way to adapt, even though you don't have the same level of information on every continent. And the other thing is that, so we at Le Monde, we don't have the resources to update constantly the map. So we have transmitted the data, the baby, to the CNRS, which is the #1 public research organization in France. And so you can note this website address where the the data sets have been updated, improved. They are much easier to use for research, and they contain also many more PFAS than you could see on the map. Because on the map we had the display tool could only show 6 PFAS levels, but in the data set now you have all the PFAS that were measured actually in the environment. Thank you. I think that was my next slide. And you can find all the publications of the project. We had like over 80 stories, podcasts, TV programs on the Forever Pollution project. Thank you very much. And over to you, Roland.
Yes, thank you very much, Stephanie. And first for your work, super project and a super map. And I think why we invited you is that often now when we think about the countries in Africa, there aren't hardly any PFAS data, but of course these countries can do this presumptive approach. Yeah, this means the first part would be what sites could be contaminated, and then from there could be a prioritization and also a first inventory for PFAS contaminated sites. So that was also part of step number 3. So now step number 4 is then evaluating and data management for PFAS. A mechanism for data evaluation is needed to identify the gaps and the limitations, the need of notifications for registration, and also the evaluation of further work. Also then what would be then the action plans, and if the information is there in the inventory report for the action plans. And also we have developed here this guidance for quality assurance, quality control, which can be used then for the evaluation of the data. The last step is the inventory report, including objective scope, data methodology, final results, including the gap analysis and the limitations, and including the recommendations for the action plans. So by this, we finish with, let's say, the major part. Yeah, only one presentation is left. But Anastasia, if there are questions, maybe we take now, especially those which came for Stephanie, because Stephanie has to go in a few minutes.
Sure. Thank you so much. And many thanks to Stephanie. That's indeed a very outstanding work. And I was very impressed by the project. I've seen your presentation in a couple of webinars before in 2023, and it's really great. I think we do have a couple of questions, but there was a question to
I mean, if you have something for Stephanie especially, and on PFAS, yeah, then we do it now.
I think a couple of people were interested about how to navigate the map, and I have shared the link in the Q&A, but if this is not the right link, if you could correct me, please.
Yeah. So we will give the link then to everybody on the publication. And these kind of information you can find in the publication Stephanie just mentioned. Yeah. And then if there are further questions, then you can directly approach us. Yeah.
Yeah. Maybe we could pick up one more question here on the PFAS. So we did have a question from Ethiopia on how can we estimate the quantity of PFAS and related family chemicals in different industrial products for consumers, so consumer products, because this is kind of probably hard to find and identify. As you mentioned, there are carpets, there's a cutlery, some kitchenware. So
yeah, I mean what I showed for Suriname, and also we published the study from Suriname. Yeah, I mean with the carpets we really did this drop test first. Yeah, and from the drop test then you can conclude if it contains PFAS or not. Yeah, there are also tests for fluorine, organofluorine. Yeah, and so this could be, let's say, an assessment which is, I mean, the drop test is possible in all countries. Yeah, it's really simple. Yeah, the fluorine test is more complicated. There are different approaches. You need to check if this is available in Ethiopia. Could be, yeah. that you have a combustion ion chromatography, for example, for fluorine. And otherwise, for products, it would need then the real analysis. Yeah, because products are normally not labeled. That's a big problem. Yeah, and so for products that you finally know, it needs analysis. Or if it's let's say a mixture like a firefighting foam, there you might have a material safety data sheet, and in this material safety data sheet, it might mention also the type of PFAS. Yeah, but we found it before in Europe even that it might mention it's PFAS, but it does not tell that it's PFAS or PFOA. Yeah, so this really you need to look, and like I mean, you saw also now with the contaminated site how important the firefighting is. So I think there you should start in the products. Yeah, quite relevant. And here, like I said, I will try that. Thailand is publishing the guidance about how to monitor POP PFAS in firefighting foams. Yeah, and then we will. You would see UNEP has a project on firefighting foam and PFAS in airports. So if at one point it will be possible to do some analysis and some monitoring in the frame of the UN and in the frame of a NIP update. Yeah.
Thank you so much. I think we do have one more question, which could be probably also interesting for both you and Stephanie. So we had a question on the example of POPs that are used, or probably even PFAS that is used secretly or unofficially. What can be done if they cannot determine the quantity because no one agrees to give the information? And again, it's probably pointing to the approach of the presumptive contaminated sites. Or maybe there could be some more hints or some more advices that countries could follow on this.
And if it's the use in a facility, I mean, you need to visit the facility, right? So the environmental ministry normally have the right to assess, or the Ministry of Industry, depends a bit who has the access to facilities, and then to really check the chemicals, yeah, the CAS numbers of the chemicals, yeah. So that would be the thing what you can do. And I mean, I have shown you the different areas which are, let's say, major areas where you would look to the industry, and on the other hand, really talk with the industry, and that the industry look in the supply chain. Yeah, especially, you know, it is also on substitution, and maybe they can get a project. Maybe they can get an exemption. Yeah, so you also need good arguments that the industry is really trying hard to get the information what they can get, because who normally knows it is the guy who sell the chemical. Yeah, so there you need finally to come to get this information.
Many thanks, Roland, and many thanks, Stephanie. I believe we are quite short of time, so we probably may continue and then get back to the questions in the very end again.
Yeah. Okay.
Thank you so much.
So the last presentation is on introduction to short chain and medium chain chlorinated paraffins and related inventory development. SCCP has been listed 2017, and medium chain paraffins are probably listed and suggested to be listed at COP12 in 2025. So paraffins are a quite complex mixture here, and they are defined according to their chain lengths. Here subdivided in short chain, which is carbon 10 to carbon 13, medium chain carbon 14 to carbon 17, and long chain carbon 18 to carbon 30. And then you have different chlorination degree. So here the chlorination degree of chlorinated paraffins are normally between 30 and 70%. And because of difference in chain lengths and chlorination degree, there are approximately 200 commercial CP mixtures in use. The Stockholm Convention listed SCCP with a chlorine content of more than 48% as POPs, but also chlorinated paraffin mixtures with more than 1% of short-chain chlorinated paraffins are considered POPs. Also, for the medium-chain chlorinated paraffins, here it is suggested that those which chlorine content of more than 45% are proposed for the listing. And when you look here to the production, it's much larger. It was estimated in 2022 that around 400,000 tons up to 900,000 tons of CP mixtures have been produced per year. And the short-chain chlorinated paraffins have received a range of exemptions. They have expired by December 2023. Also, China has restricted short-chain chlorinated paraffins end of 2023, but India did not ratify short-chain chlorinated paraffin yet. Yeah, like I said, there was a range of exemptions. One slide more on production, where you see over the last 20 years, this strong increase in production has happened. Since about 2010, the production was about more than 1 million ton of total chlorinated paraffins. And it was actually a Chinese study which estimated that the share of this one from the 1.4 million tons were about 400,000 tons of short-chain chlorinated paraffins. But because the short-chain paraffins are mainly in mixtures, we have estimated that when you look how much percent of mixtures, above 1% of short-chain chlorinated paraffins, it was rather 900,000 tons. The major producers are China with 700,000 tons or more, and it's estimated that India might produce somewhere between 300 and 400,000 tons. There are further producers in Egypt, Russia, Qatar, South Africa, United States. So the exemptions which have been listed for short-chain chlorinated paraffins were also at the same time the major uses. This means flexible PVC in rubber, especially here transmission belts. Then in fat liquoring liquids for leather, in different lubricants for a wide range of uses, in metal processing, in waterproofing and fire retardant paints, and also in adhesives. So also, these exemptions have expired. Most probably still SCCPs are produced because India has not ratified yet. And also often the producers of the chemical did not know what they are producing because they cannot measuring it. Yeah. So therefore, probably still SCCPs or at least CP mixtures containing SCCPs more than 1% are produced. Then the largest amount of chlorinated paraffins are the medium chain chlorinated paraffins, which are produced probably close to 1 million ton. So they will be listed in 2025, and already there is a long list of proposed exemptions for medium chain chlorinated paraffin. You can look at it at this POP reviewing committee document 20/3. And we will see if at COP more exemptions will be asked for. So here, when we consider that there will be exemptions for 5 years for MCCP, they will be at least probably produced until 2031. And for metalworking fluids, already there is an exemption until 2036. So this means that they will be long with us. Interesting is that PCBs, polychlorinated biphenyls, and polychlorinated naphthalines have been used in the same open applications. Yeah, in sealants, paints, plastic cables. So therefore, when the SCCP and MCCP have substituted the PCBs in these open applications, mainly in the 1980s, and 1970s. So therefore, when you do an assessment of the stock of short and medium chain chlorinated paraffin in these uses, at the same time, you can also check if there are remaining PCBs and PCNs in these uses, because the service life of such sealants and paints in buildings can be very long. What you see is really here with PCBs and chlorinated paraffins, the substitution here in the sediment core in Switzerland, where you see here the PCBs have increased in release to the environment until 1970. And 1972 was the stop of PCB in open applications. And you see what strong reduction this had for the PCB in the sediments. Also here, PCBs here in Switzerland have been used in the transformers and capacitors also until the middle of the 80s. Yeah, but you see the closed application for environmental release did not have a real impact. Yeah, so a large part of the PCB pollution of the world come from this open application. At the same time, you understand how relevant this open application for the chlorinated paraffins are. So they are released to the environment. And what you see here is how they have increased in the sediments, yeah, from the 1950s, 70s, 80s, 90s, yeah. And today, when you compare the concentration, the chlorinated paraffins are already 3 times higher. So here is the amount of chlorinated paraffins, 60 nanogram per gram in sediment. And the peak for PCBs was 17 nanogram here in Switzerland. Yeah. So you see here for the environment, larger pollution by the chlorinated paraffins in these open uses. And the same we find in human milk today. This is our data from the WHO UNEP human milk study in 65 countries. You see the chlorinated paraffins are higher compared to PCBs and all others. The only one which has a higher concentration is the DDT, which is also openly used directly in the house spraying. But they have a lower toxicity compared to PCBs, but sensitive endpoints like developmental or neurotoxicity for children have not really been assessed, that always take decades. In respect to this human milk data, I need to highlight that mother's milk is still the best nutrition for the baby. So the benefits are bigger than the drawbacks with the pollutants. So when you look here to the different countries, you see that Africa and Asia has relatively high levels also of chlorinated paraffins in human milk. And when you do here, Dr. Fiedler did a study and evaluated from this human milk data that the poorer countries had higher levels of short-chain chlorinated paraffins in human milk compared to the richer countries. Yeah, one reason is it goes into very cheap PVC products, which are finally used in your country, and you see here how relevant this assessment and the inventory is. Especially here are data from Africa. These are dust in South Africa, in the house dust, where you have between 135 to 228 mean concentrations of chlorinated paraffins and a maximum of 350 milligram per kilogram. This means ppm in your house dust, yeah, with a maximum of up to 660 milligram per kilogram. Yeah, so you see here a considerable share of your house dust is chlorinated paraffins in Africa. Yeah, so medium chain were the dominated chlorinated paraffin group, more than 60%, short chain chlorinated paraffins around 22%. This is another study here, house dust, Australia, Japan, Cambodia, and Thailand. And also here you see with Thailand the high levels of especially here the yellow one is the medium chain chlorinated paraffins with lower concentration of short chain chlorinated paraffins and long chain chlorinated paraffins. Yeah, also here 100 milligram per kilogram level, and the release is most probably from plastic and construction materials, but we will come to that. Yeah, this is also based, my conclusion from this Chinese studies, excellent study from Beijing University. They have measured 124 products on the Chinese market, and they have found very high levels in PVC and in rubber and in polyurethane spray foam used as adhesives and sealants in buildings. Yeah, so they were the major use. They have also, this group has also done a global review article I would recommend you to have a look at, where they estimated that today on the globe, around 60% of chlorinated paraffins are going into PVC, then less than 20% into metalworking fluids, less than 20% into rubber, less than 10% into sealants, adhesives, and then around 5% into paints and varnishes. This estimate is missing, let's say, data from India. So therefore, I think that maybe paints and leather might be underestimated. We need more data from India to conclude, but it's already a very good overview. Just one study from Germany. These are baking ovens from Germany. 50% of 20 baking ovens were inside completely contaminated with chlorinated paraffins. So this came from the cable sheetings in the and plastic parts, PVC parts in the baking oven. So when you heat the baking ovens, the chlorinated paraffins go out of the baking ovens and go directly into the food in the baking oven. So this research group also did a study on that. So therefore, now we come to the inventory guidance and to the inventory of chlorinated paraffins. I developed quite detailed inventory guidance here. You have good background information here. Chapter 2, how to conduct the inventory, chapter 3, and then inventory chapters from 4 to 9, including looking into the production and into import-export, into the manufacturing of products, then into lubricants, products and use in stocks, and into waste and on contaminated sites. So that's the structure, and we will quickly go through these. First to the imports and possible exports. So SCCP and other chlorinated paraffins containing more than 1% cannot be imported or exported for the use since the exemption have expired. Yeah, medium chain chlorinated paraffins is not listed in the convention, so therefore it can be imported and exported depending on the legislation of the country. Commercial chlorinated paraffins which contain more than 1%, but are normally not labeled, but they are considered POP and SCCPs. Yeah, and this is what for sure happens frequently. So such imports and exports should be evaluated and recorded in the inventory, including the quantities. SCCPs are listed in Annex 3 of the Rotterdam Convention and are subjected to the prior informed consent procedure. However, it is not clear if this procedure is used by exporting countries. Yeah, so also here, please put in the comment if anybody of you have ever seen or done a PIC procedure for short-chain chlorinated paraffins. So for CP mixtures, CAS numbers and trade names are available for looking, and also HS codes to search on the custom level. Unfortunately, these HS codes, which are now normally used for the import and export of chlorinated paraffins, are unfortunately not specific. So even not for chlorinated paraffins. Yeah, so therefore, on the custom level with the HS codes, you can only guess the groups of chemicals where the chlorinated paraffins are in. So you would need then to do further assessment, for example, by looking to the companies which have imported, or by a more detailed assessment on custom level. If you have a global harmonized system in your country where the CAS numbers is given, then you can look for the CAS number. Yeah, and here the inventory guidance include CAS numbers here for chlorinated paraffins, where you can check if it's chlorinated paraffin, or even check if it's short chain or a mixture of chlorinated paraffins. Also, trade names are given by the inventory guidance, and there are some data from India of exports of chlorinated paraffins on individual countries. I have copied here the record of export of chlorinated paraffins from India to Brazil. Yeah, here for 2013 per month, around 500 tons have been exported from India to Brazil. Yeah, so also here you can do a short first assessment. If you can find such exports from India to your country as a first indication. Then in the next step, you would need to contact the importers of these chemicals and request further information and data about the import quantities of chlorinated paraffins. If he knows if it's short chain and medium chain chlorinated paraffins, then to compile the import quantity of these chlorinated paraffins. If you are a producer, then also assess the export quantity. What are then the downstream uses? So if you have a company which are importing the chemicals, the chlorinated paraffins, then you might get information from them to which companies they are sending it. We have done an inventory for Brazil, which is also published, and I recommend you to read it, Jago et al. And also he has done this approach and found 2 importers, and then to do an assessment to what companies this chlorinated paraffin goes for further production. And here the inventory guidance have 6 major industries. These are the PVC production, the rubber production, the paint production, the leather production, the production of adhesives and sealants, and the production of textiles. Yeah, and the major uses are in PVC and rubber and in sealants. Yeah, these are then the use in production. So here, assessment if any of these productions are present in the country, and then to look to these sectors and to check if chlorinated paraffins are possibly used in the manufacturing of products. So this would be your assessment for these industries. For this assessment of the industries, we have also developed questionnaires. So these questionnaires are annexes in the SCCP inventory guidance. Like I said, the major use seems to be PVC. For SCCP and for MCCP, they are here secondary plasticizers in flexible PVC. Also, PVC is listed in the recommendation of exemptions for the listing of medium chain chlorinated paraffins. And here you would do assessment of production of PVC products and the used additives in the countries. There are also non-chlorinated paraffin plasticizers, yeah, like for example the phthalates, yeah. So flexible PVC has then also many applications. It goes into cables, into plumbing, into conveyor belts, yeah. And you would do the assessment first if they are using it, and if they are using it, then you can also check into what product this chlorinated paraffin goes and the related exposure and exposure risk. For the use of PVC, it is also possible that pellets, so-called master batches, already containing short-chain chlorinated paraffins could be manufactured outside the countries and then imported into the country. Yeah, so that would also be a part of your assessment. And what we have done, so we had a question now from Ethiopia about how can we do an assessment of products. And for PFAS, it is nearly impossible, yeah, for textile, for example, if they contain PFOS, PFOA, or other PFASs. But we have developed, because I saw this problem, I have developed a methodology which we now used in some countries where we did an assessment of the import of chlorinated paraffin in products. And this methodology we have developed in pilot projects in Brazil and South Africa under the BRS Secretariat and in Nigeria, and have also published it. So what we have done is, first, we have looked to the major uses. These are plasticized PVC, plasticized rubber, and plasticized adhesives, yeah, polyurethane foam especially. So here we know the HS codes. So from there, you can do first a complete assessment how much of plasticized PVC is imported to the country by the UN Comtrade database. So this is the case study of Nigeria. We have published, you can look to the details here in the publication, where we have found huge amounts, and here we are at 200,000 tons between 1996 and 2018, more than 200,000 tons of floor, wall, and ceiling coverings, more than 250,000 tons of PVC sheets, films, and foils. Yeah, and this is the first step. And then we have this good data from the study in China on the chlorinated paraffin content of PVC products in China. And these are not only used in China, but these products are exported. Yeah. And so therefore, what we have done is we have used these impact factors from the study of Chen et al. Yeah, for the PVC, but also then for the rubber, which have been imported to Nigeria. So also here you see for the rubber, we have a range of HS codes, and there you can look for the HS codes, which are plasticized rubbers. And we have done the same for the plasticized rubbers, also done a complete assessment for Nigeria of the import of this plasticized rubber between 1996 and 2018. You see here one major use where we know is conveyor belt, transmission belt, but there are also other here articles of vulcanized rubber, which are not hard rubber, so might also be plasticized. Yeah, and also for this we have used the impact factor of the Chinese study. And the third area, we have made an inventory of the import of this polyurethane foam and the adhesives. You see here, this is a study from Europe, so it's not only China. Also in Europe here for the polyurethane foam, you see that these are 10 different polyurethane foam in 2021 on the European market. And the blue one is medium chain chlorinated paraffin in this polyurethane foam. Yeah. So this is the foam probably everybody of you have in your house. Yeah. Which you use, to seal the window when the house was built and so on. Yeah. And this contained up to 50% medium chain chlorinated paraffin. Yeah. The same in China. In the study, they contain medium chain and short chain chlorinated paraffin. Yeah. So we have now for Nigeria done the assessment for PVC, for rubber, and for this adhesive and polyurethane foam. And we have multiplied it by the average impact factor. And what we found is that by PVC imported to Nigeria between 1996 and 2018, around 33,700 tons of short-chain chlorinated paraffins have been likely imported from PVC from China alone to Nigeria. Yeah, and these data, I think, are relatively robust. I don't think that we are wrong by a factor of 2. Yeah. Also, they contain medium chain chlorinated paraffin. Here, the impact factor in China was a little bit less than short chain chlorinated paraffin, but also more than 25,000 tons of medium chain chlorinated paraffins in PVC imported. For rubber, the content of SCCP, the average content, was lower here in China. So the estimate then for the import of all the rubbers to Nigeria was 1,300 tons of short-chain chlorinated paraffins and 32,000 tons medium-chain chlorinated paraffins. Yeah, and for this adhesives polyurethane foam, we estimated more than 2,000 tons short-chain and 2,000 tons of medium-chain chlorinated paraffin. And the major part of this PVC is going into construction, and basically all of this polyurethane foam is also going into construction. Yeah. And in my opinion, this explains the high levels which we find in houses in Africa or in Thailand. Yeah. So when you do here the inventory for sealants, then what I said, the same can be done then for the stocks. Yeah. Here including then the PVC. The main sealants are here the sealants in concrete buildings. This can be outdoor sealants. This can be indoor sealants. This can be sealants around the windows. Yeah, so they can contain, when you have a sealant from the 1970s, which contain chlorine, so you can screen with the XIF. It might be PVC, it might be PCN, it might be chlorinated paraffins. One very good country study is from Switzerland. They did an inventory of PCBs and chlorinated paraffins in the sealants. So Switzerland found that 30% of the sealants tested contained PCB in Switzerland in the houses built from 1950s to 1975. They found that a third of all pre-screened chlorine-containing sealants contained chlorinated paraffins. This means also a high share. Yeah, and so this is really something easy you can do. XRF, you screen the sealants of the building, you understand if chlorinated compounds are there, and we have a first pilot study in South Africa, a PhD thesis. Then chlorinated paraffins have been used in paints and are still used in paints and coatings as plasticizer or flame retardant to improve resistance to water and chemicals and reduce flammability. SCCPs have received exemption until end of 2023. And also for medium chain chlorinated paraffin, it is proposed to get an exemption for paints. Yeah, and here these are often specific paints like this intumescence coatings, printing paints for textiles, chlorinated rubber system in swimming pools, paints for walls and flooring, paints for the streets. Yeah, so the street marking paints, for example. Yeah, so but you would do then the assessment first on your paint producers. So you would go to the paint producers, check what kind of additives they are using in their paints and if chlorinated paraffins are there. Then you would do an assessment of the imported paints if they contain chlorinated paraffins. So normally, if there is the right material safety data sheet, you would see it. If you have if you would have a GHS, Global Harmonized System, in your country, and if it's more than 0.1% in your paint, they would need to tell what is in the paint mixture. Then to look to the reservoirs, and very interesting how these paints are removed at the end of life. Because what we have found in Europe, that these PCB paints here from bridges or from this electricity pilos, that they are removed by sandblasting. Yeah, and by this we have in Germany one river completely contaminated with 600 kilograms of PCB. Or in Norway, there was one bridge which contained alone in the paint more than 1 ton of PCBs in the paint, which was removed and contaminated the whole fjord. But these paints are also used in machineries and, like I said, in swimming pools, for example. Here in Switzerland, it was estimated that 20% of the outdoor swimming pools are PCB paints, and might also contain another 20% or 30% chlorinated paraffins. So then metalworking fluids and lubricants, some uses are in production processes and not in products. So here, these metalworking fluids you are using in metal cutting. The lubricants you are using, for example, in automotive as engine oils, transmission fluids, or gear oils. In industrial automotive, like heavy-duty vehicles, agricultural equipment, construction and other earth-moving equipment, military, rail, ships. Yeah, so very wide use of these lubricants. And also here, lubricants were exempted in the Stockholm Convention and ended 2023. But medium chain chlorinated paraffin will get an exemption, at least for metal working fluids, until 2036. Yeah. So, but the important thing is also that by this use, it's directly released to the environment. Yeah, it's a total or partial loss application. So therefore, at these companies, you would also at the same time have contaminated sites. Yeah. So therefore, you would do an assessment of the lubricant production. You would look lubricants imported. Yeah, if they contain chlorinated paraffins, what chlorinated paraffins, and then also for the metalworking fluids, and how are the metalworking fluids and the lubricants released in the companies, and how contaminated are the areas. Then we have the fat liquoring. So here the fat liquoring is the last step in the production of leather. Typically, you use around chlorinated paraffins in typically 10%. In this fat liquoring range is 5 to 20%. So, and around 1 to 5% are also in these processes released to the environment. This means also around these leather production companies, you might find contamination from the use of this fat liquors. And but SCCP had a fat liquoring exemption, which expired also in 2023. And at the moment, for MCCP, fat liquoring is not yet suggested as an alternative, but we will exemption. But we will see then in the final listing. Assessment would be if fat liquors are produced in your countries, then if short or medium chain chlorinated paraffins are used in this production, if the fat liquors are imported to your countries containing short or medium chain chlorinated paraffin, and then assessment of these contaminated sites. A last slide for products. So in Europe, we did an assessment of consumer products, and if they contain more than 1,500 milligram per kilogram of short-chain chlorinated paraffins, and what we found is that this is the case in many products. Here, toys, plastic dolls, toy doctor cells, bouncing toys, stickers for children, rubber knife, toilet seats for children, sports equipment, beach ball, baseball gloves, fitness gloves, yoga mats, you can name it, long list. And many of them are produced from PVC and from rubber. Yeah. So you see, before I said, okay, this is the import of PVC and the import of rubber. Yeah, this can also be really big pieces for construction, but it can also be already the products. Yeah. And many of these products have directly exposure here into houses and directly exposure into human. And of course, these uses will finally impact recycling streams and circular economy. So the secondary plasticizer in flexible PVC will impact PVC recycling the next decades. The use in rubber will impact rubber recycling for the next decades. The use in polyurethane spray foam will impact construction and demolition materials and their use. The metal cutting and lubricants will impact oil recycling. Yeah, leather contaminated might impact leather recycling, and also the paints which are used in buildings impact here the recycling. So in Germany, for example, for PVC, we have a limit of 5 milligram of PVC in construction debris. And if you have a PVC painted building, you are above the 5 milligram normally. Yeah. So therefore, future recycling problems ahead. And the World Chlorine Council at the POP Reviewing Committee has proposed an exemption for PVC recycling, but by this recycling again, you will bring back the POPs into new products. So you see, very important topic, very relevant topic, and very important inventory task. Yeah, thank you for your attention.
Thank you very much, Roland, and thank you very much to all the participants for staying with us till the end. I think we are quite out of time and behind the scheduled time.
But
so
if there are
maybe
questions,
we do have some
questions, you know.
We do have some questions on the PFAS and on the first part of the presentation and on the second part. So maybe we could pick up the question on the second part and then come back to the PFAS and address other questions in writing by email. So the first one is, I think the complicated parameter to quantify will be SCCPs and MCCPs. Hence, how can we estimate it? So it was probably in the beginning of the session. So the number will be increasing astronomically. What about the alternatives of these pollutants? So I believe some of the points were already answered during
so first about the analysis. Yeah, I mean, it is possible to analyze. Yeah, and we have developed also. I mentioned to you that I have developed the guidance of monitoring POPs in products and recycling. And please download that guidance. It's a real nice one. So for all these POPs, industrial POPs, we have a detailed explanation on how to analyze. And for the chlorinated paraffins, we have included also a low resolution method for the analysis. And low resolution GCMS are often also available in African countries. Yeah. So this method, and that was the reason that we also included a low resolution method, can be used. And if you develop a halfway reasonable analysis, but you need a good standard for that, yeah, then you can also quantify and analyze if it's a short chain or a medium chain chlorinated paraffin, or how much percent short chain and how much percent medium chain chlorinated paraffins are in mixture. Yeah, so that's possible, and the methodology is included in the Stockholm Convention inventory guidance for monitoring POPs in products. Yeah, it's on the website.
Thank you so much for this, Roland. And I think we could also probably share the links to relevant studies and guidance documents after this webinar to the participants. Yeah, in the follow-up email for sure. Let's pick up 2 more questions on the first part of this presentation. So the first question is, can we consider car seats as a category during inventory of PFAS? And the second question is also on the PFAS is, can we assume that all firefighting foams in airports contain PFAS? So these days there are fluorine-free firefighting foams available as alternatives to PFAS.
Yeah,
so
we start with the firefighting foam. Yeah, we start with the firefighting foams. I mean, presently in developing countries, more or less all firefighting foams at airports will be PFAS foams. Yeah, and if they are a bit older, they probably contain PFAS or PFOA. Yeah, but there was also a change. So today the PFAS foams are normally C6 foams. So it will depend when and where you bought your foams. Yeah, because there are also still until recently PFAS foams. Yeah, produced. So they are, like I said, I love the approach of Thailand to develop that guidance document, and they do a complete inventory of their foams in the country, and the airports will be a primary aim, which will be analyzed first. Yeah, so there is a UNEP project on non-fluorinated foams and the use at airports, because, for example, in Germany, in most of our airports, we have already substituted the PFAS foam with non-fluorinated foams. Yeah, so this is possible, and the non-fluorinated foams are also not more expensive, but you need some different. You need some change in the approach how you apply the foam. Yeah, and maybe even you might need another equipment to spray the foam. Yeah, so it's not just a one substitution. Yeah, then for the first question, it's a very good question, and actually I have the same question. Yeah, so you asked about car seats, and yes, I think that car seats contain often both. They contain repellent, and this repellent is often a PFAS. Yeah, so here you can do the testing which I showed you, and also let's say the fluorine testing. One thing is what you need to consider, that probably on this textile, the PFAS used is a side chain fluorinated polymer. So this can also be PFOS or PFOA. Yeah, but it is covalently bond to a polymer. Yeah, so to really analyze it and to quantify the PFAS, it is a bit tricky, and also often the textiles are flame retardant in car seats. Yeah, many of them contain DKBDE. Yeah, in Japan, the major use of DKBDE in vehicles were car seats, the textile there. Yeah, so car seat textiles, yes, is relevant, and the management of car seat textiles, I think, is a relevant issue, because we do not want these chemicals finally in the landfills, because PFAS over time will leach. It's only a question of time. Also, the side chain fluoropolymers, US EPA did a study on their degradation. They are degrading, but they are degrading at a time rate of decades and up to century, but they are degrading. This means then your landfills where you put your PFAS-containing textiles and carpets will leach these PFASs rather for centuries. Yeah, and this is one more reason and argument why we need to manage these and probably think how to destroy these in end of life, for example, in cement kilns. Yeah, much better than to have them in landfills and dump sites leaching. Also, what I have observed, there is a study of phosphorus flame retardants, chlorinated phosphorus flame retardants in South African landfills, huge levels. Yeah, and I also think this comes probably from electronic waste and from car shredder residues, which contain large amount of these phosphorus flame retardants. So here you need to take care not to contaminate this, and they are mobile. You know, the PFAS are mobile. The dioxins, when you have it in the landfill, they're in the landfill. Yeah, but the PFASs are migrating, and then they can move with the groundwater, or they can move hundreds of meters, yeah, or kilometers over the decades. Yeah, so there will be pollution around landfills in future. Yeah, I see this as a huge problem and as a part of PFAS contaminated sites.
Thank you very much, Roland. And I believe it's time to wrap up as many of participants are also leaving. So that was a very technical and very heavy session to digest, but at the same time, I believe very insightful and very helpful to most of our participants. And just a quick reminder, we're having one more webinar on the UPOPs inventories on the 19th of September, so please feel free to register and attend. This webinar is recorded, so we'll share the records and the materials, including the links to the studies mentioned by our speakers and the guidance documents also mentioned during this webinar, and answers to your questions if some were not addressed in our follow-up email after this webinar. And many thanks to all our regional executing agencies. Most of them attended today, our countries, our participants, and our interpreters for sure. Many thanks to Dr. Roland Weber, again, very insightful and great job hosting this for 2.5 hours. That's amazing, and thanks for inviting also Stephanie. That's really a great part of this webinar. Many thanks, and see you again on 19th of September.
Yeah.
Thank you.
And wish you good progress all, yeah, with your inventories and with your NIP updates, yeah, and other work you might have on POPs.
Indeed. Thank you. Bye everyone. Bye.